I want to go to Mr. Michael Boyd. Let me see. I will ask him to unmute, and I should do a quick intro. So Michael Boyd is going to do Apache UAP infrared video analysis. On November 6th, 2018, the pilots of U.S. Army AH-64 Apache attack helicopter were on a training flight in Arizona. They spotted 3 UAP doing wild maneuvers in the sky, not too far away and not particularly high in the sky. So in this presentation, Michael Boyd is going to review the FLIR footage from the training mission and offer suggestions on gravity modification based on distortions in the footage. And Michael actually has lots and lots of footage, so we may see stuff come up from other UAP incidences as well. So Mr. Boyd, are you here?
Yeah.
Okay. Yeah, let me spotlight you. And yeah, I would say take it away, sir.
Okay. So what's going on? I appreciate the opportunity to present this. I went to a UAP disclosure symposium in Vernal, Utah, where beforehand they gave me a access to these 4 recent videos that the government said substantiated were in fact sourced from government records. And I worked on it with this guy. His name's Stephen Leah. He's an image analyst. And so some of the data I'm presenting is from him. And I always like to bring humor to the fore. We're going to be talking about time travel, and this is a good question. So now what I'm going to talk first about is I have these several patents on what's called a method and device to produce gravitomagnetic induction. It's called a mass spin valve or a gravitational rectifier, a gravity diode for short. And what I have here is an image of your hard drive in your computer. And on the right is, if you open the lid up, this is what you'd see. You'd see the disk, and in the middle, the little ring, the ring sits on the spindle, and then there's like a little arm there, and below that picture, you'll see an image of a merged read-write head. This is the electronics. These are real tiny. They're all at the nanoscale. You could barely see any of this stuff. And there's basically 2 components on you have a write head, which is a little magnetic coil. And what it does is it writes these little domains on the surface of the disk. And you'll see below there's like north, south. It's a little magnetic domain. And that's how the data is, the data is recorded. And then it's read back. On the left of that is a what's called a magnetoresistor, or a giant magnetoresistor. It's obviously not because it's giant in size, but it's because it's very sensitive to changing magnetic fields. On the left here is a circuit diagram of this. Basically shows all the hardware and including, it's got analog circuits, it's got digital circuits, it's got a clock, it's got a control for the power and everything. And then there's a little image here where I've blown up what the head actuator arm looks like in your hard drive. You'll see it's a stack of them because you have several of these disk platens are called in your hard drive. So now what I did is I fabricated these little nano bumps and nano pits. On the left there, you'll see the pattern and the dimensions that go with all the little nano bumps and nano pits that I fabricated. And then they're basically on a radius of the disk platen, as you can see on the right there. And then on the bottom, on the right there, that's basically a cross-sectional view of what the hard drive disk platen has on it. It's mainly just a big piece of aluminum with certain layers on it. Only one, the magnetic layer for the read and write data, is only like 30 nanometers thick. It's not very big. And then basically on the lower left, I have a cross-sectional image of the device. You have a little nano bump there, and it's like the 10 micron square one, and the disk is turning counterclockwise. And then I'll explain the assembly of that in detail a little more. Now, looking at the nano bumps and nano pits, what I'm showing here is that when we're talking about space-time, we're talking about the presence or absence of matter moving relative to this sensor. And so in this case, when you go over the nano pit, it's a region of expanded space-time. And when you go, when the nano bump goes under the sensor, the sensor is only 100 nanometers away, just for your information. So it's sensitive to the increased density of space-time as the bump goes under it. Now here's some actual data from the 10 micron square nano bump on the disk. It's spinning counterclockwise. Gravitation is slower than the speed of light in the context of frame dragging. As you can see from the data here, there's these two electromagnetic peaks. The one on the left, that's the first one, and that's produced by the switch in the angle of the magnetic field relative to the sensor. When it hits the edge, the magnetic induction produced by that switch in the field direction at the speed of light reaches the sensor, and then followed by that, as you move to the right, you'll see the gravitational induction signal produced by the defect's mass. And then you'll see the second electromagnetic induction as the edge of the bump goes down on the other side. But you can see there that from this context, the electromagnetic signal of the first electromagnetic induction signal on the left proceeds before the gravitational induction signal. So in this case, gravity is going slower. Now here I have this like cross section where we're looking at the bump and we're looking at these different sensors that I had. The arrow on the bottom right points to where the location on this sled-shaped thing is called a slider. And sitting at the bottom of the slider is the little reed head that I showed in an earlier slide. And that's the same signal that we saw before in the previous slide, except that it's at 2 microseconds per division instead of 1. But you can see the induction electromagnetic induction signals are in the same location. Now, the other thing that we do is we have on the back side of the slider, you'll see this little green area. And what that is that's a piezoelectric sensor. And with a piezoelectric crystal, if you tap it, it creates a signal. Now, so on the left, bottom left is the readback signal from the piezoelectric sensor, and you can see as the bump spins under the GMR sensor, or the head slider in this case, it actually physically pulls it down. And when it goes by it's kind of like a spring. It goes like boing, like that. And that way we can tell that's actually a pull force. And that goes with the negative polarity gravitomagnetism. Now, the absence of matter produces a push force and a positive gravitomagnetism. And now we look at these same signals again. The one on the right lower is the gravitomagnetism signal. It's got a positive polarity. And then if you look on the left lower, you see there's a little push signal. And the way we know it's a push is it's dampened because it's pushing against gravity. And you can see in the cross-sectional diagram here, the Earth's gravity is down. Now, when you take all the different nanobumps and nanopits and you plot the data, I noticed what you get, a diode curve. A diode is a semiconductor device that lets you push current one way or the other, depending on the properties of the semiconductor. Now, in the semiconductor physics, the P-type side is called the acceptor side. It has an excess of what are called holes. Holes represent protons or positive charge. And then the N-type side is called the donor side. And that's where there's an excess of electrons. And this is in semiconductor physics. What we're observing here is the same effects for the gravitational induction and anti-gravitational induction. Now, the thing that's kind of interesting about this is bumps produce a 1/distance squared dependence, like normal gravity does. But the anti-gravital induction is 1/distance cubed dependent, which is kind of like what I'll bring up later. Is it's interesting because it's balloon-like. It's only strong at the membrane, not strong in the middle. Now I want to talk about quantum tunneling a little. Can you guys see that okay?
Yeah, no, that works fine.
Okay. Quantum tunneling shows how profoundly particles such as electrons differ from bigger things. Throw a ball at a wall and it bounces backwards. Let it roll to the bottom of a valley and it stays there. But a particle will occasionally hop through the wall. Pardon. In 1962, physicist Thomas Hartmann found that a barrier seemed to act as a shortcut. When a particle tunnels, the trip takes less time than if the barrier wasn't there. Even more astonishing, he calculated that thickening a barrier hardly increases the time it takes for a particle to tunnel across it. This means that with sufficient thick barrier, particles could hop from one side to the other faster than light traveling the same distance through empty space. Now, I using this interview with a time traveler from the future that describes the what's called offset spatial divergence.
Okay, yesterday you told us you traveled thousands of light years to get here. Tell us to move to forward or the moon.
Now, there's this guy that his name's Harold Howe Putoff, and he did this paper, Advanced Propulsion Based on Vacuum Space-Time Metric Engineering. And in here, what I have is a copy of the table from table 1 of his paper, and I have the link there. And basically, if we assume there's a standard time and a standard length at sea level, as we move away from the Earth, we are going into a region of what we would call expanded space-time. And as we go towards the Earth, or towards a stellar mass in this case, we see the opposite effect. In denser space-time, time dilates, the length shrinks, and we experience this, what's called a gravitational force. As we go away from the Earth into space, for example, we go into expanded space-time where time shrinks, length dilates, and we have this anti-gravitational push force. And it's basically, in this paper, he talks about this. This also can have harmful effects when, for example, you go into expanded space-time. And I have this little video for that.
Is there anything you can learn from this that could help us in terms of evaluating observations in the world associated with unidentified aerial phenomena? I'll just give you one example. And I have about 1,000 I could give, but I'll take a week or so. In this room, most electromagnetic energy you can't see. Why? Because it's in the infrared and for your feet. And there's a very narrow band in the electromagnetic spectrum that you can see, and that's what we call, the visible spectrum. And then there are higher frequencies in the ultraviolet and beyond that we don't see. Now, it turns out that one of the side effects of engineering the space-time metric to get this kind of flight performance is that we call it blue shifts the frequencies. All the frequencies that involve get moved to a higher frequency. It's just built into what the equations say when you generate these anomalous effects. So what that means then, and it has significance for us, is the infrared we don't ordinarily see gets blue shifted up into the visible. So when we hear that these craft are so bright and so luminous when you see them, it's not a surprise. And then what was in the visible spectrum gets shifted up into, let's say, the ultraviolet. And so if you get too close to one of these things that are powered up, you'll get a sunburn, often reported by people who claim to have gotten close to a craft. And if you get too close, you might actually pick up some of the blue shifted radiation from the visible that's now blue shifted up into the soft X-ray region. You get radiation poisoning. And there have been cases where that's been reported. So having this set of equations and seeing what they predict, and then going out and matching it against your data, and that's really a boon.
So now I was exploring time travel in a discussion with Hal Putoff on LinkedIn. Let's assume the speed of light is our fixed reference, fixed time reference, with the gravitational interaction time being our variable. With expanded space-time, time shrinks, length dilates, so an anti-gravitational pre-signal would be expected. We observed this effect from our 10 micron square nanopit as shown. To a non-expanded space-time observer, objects moving in expanded space-time appear to exceed the speed of light. This is an example of offset spatial divergence. Likewise, with denser space-time, time dilates, length shrinks, a post signal would be expected. We observed this effect for a 10 micron square nanobump as shown. You can see the post signal there. Our emissions. So I put this little warning sign in here. Tim, how am I doing for time?
Oh, you're doing great. Babe, we're pushing 2:30, so you got lots of time.
Oh, okay. So wait, I'm having difficulty seeing something here. Did I get I got to restart it. Sorry about that. There we go. The hypothesis here is that the manifold of events in space-time is a substance independent of the matter within it. This has been called space-time substantialism. That electromagnetism is in space-time A, let's call that space-time EM space-time. And that is what Einstein's on the electrodynamics of moving bodies described, which reconciled Maxwell's equations for electricity and magnetism with the laws of mechanics, but introduced major changes to mechanics close to the speed of light. This later became known as Einstein's special theory of relativity, or SR. That gravitation is in space-time B, let's call that space-time G space-time. And this is what Einstein's general relativity, GR, described. According to general relativity, the observed gravitational attraction between masses results from the warping of space and time by those masses. When I write about this manifold of events in space-time are a substance which exists independently of the matter within it, this manifold of events in space-time is the property that makes time as we measure it the emergent positive arrow of time. Therefore, time's a vector whose direction depends on your position in our universe, which is created by a change in energy states between gravitation and electromagnetism and vice versa. Below here in the fine print is all the links to the art, or not links, but the references to Einstein's papers. So now I want to talk about space-time metric engineering or general relativity effects. Looking at, hold on. Okay, we're looking here at the tic-tac, the FLIR 1 tic-tac video. So greater G forces mean times dilates, length shrinks gravitational energy, while lower G force means time shrinks, length dilates, and anti-gravitational energy. This is based on the principles of general relativity, Einstein's theory of geometric gravitation, and the data. And here we see some data that shows this. We see denser space-time here, and we see expanded space-time here, as I'll explain in the next slide. So you see the dark balloon, there's a dark balloon here above the tic-tac UAP, and it's rotating counterclockwise. You'll see another there's a little one down here that's going clockwise. And then you see this is also expanded space-time over here. What's interesting is this balloon region is you see it's a balloon force. It's strong at the membrane, but not on the inside. And so now, under Howell-Puthoff's hypothesis, this is the expanded space-time regions here. This is also the P side, or the acceptor side of the gravitational diode. We also have a little smart, this region I'm talking about over here, where it's going clockwise, but it's also anti-gravitational. And then over here, we have this on the right, you'll see the balloon-shaped brighter region here. It appears warmer on our iron sensor. Under Puthoff's hypothesis, denser in the light or balloon. This is also hypothesized to be the donor side, or the N side of the gravitational diode. And then I note there's this other region down here where we have both the darker and the brighter regions moving in and out, like kind of oscillating. And the hypothesis is here is this is like in the semiconductor, at the junction is what's called the generation recombination region. And the hypothesis is that's what's going on here. Now, we'll see the importance of these denser space-time regions to propulsion in the next slide. Above the UAP is the anti-gravity balloon. The left of the image is where a wormhole is opened, and the right side is where the UAP is space-time engineering, kind of like a gravitational bow, like in a bow and arrow, where the UAP is the arrow. The video shows the arrow being released, aka going warp drive. And these are special relativity effects. You'll notice as the tic tac moves to the left, it gets longer, and that's what would be predicted in general relativity. That essentially, as it goes into expanded space-time, the length dilates, time gets shorter. And then I have an example. If you watch the tic tac video, you'll actually see this. It's using angular velocity. It's basically spinning around in a little loops. And by doing that, it can increase the angular acceleration. So you can get greater accelerations using this spin mechanism. And then the other thing is tic tac seems to hit an EMP pulse, hits the thing, and hold on. It appears the UAP is hitting the Nimitz aircraft with an EMP pulse, which saturates the IR detector. When it lights up in the back there, you can see the electric readout. So that means that it had to get somehow an electric pulse to the back of the sensor array, behind it, not in front of it. And the sensor sits in a cryogenically cooled vacuum chamber. So it's a mystery how it did this. And it basically made me feel uncomfortable when I saw it, because I'm into nonviolent communication, and I needed reassurance that we don't need to have this kind of interactions with UAPs, I would think. So now I'm going to talk about solar flares and the coronal mass ejection. In a solar flare, photons of EM reach the Earth in 7 minutes, and in the coronal mass ejection, a wave of protons that follows showering the Earth with the sun's relativistic speed proton flux 3 days later. It's like a big wave in the ocean of protons, and when it hits the Earth, it causes the Earth's magnetic field to spin around. Now, it's been found that these solar flare coronal mass ejection signals slow the radioactive decay rate a day before it happens. Back to the Future.
Thunderbolts project at thunderbolts.info. For many years, a scientific controversy has been brewing far from the spotlight of mainstream media. How constant are physical constants? For decades, the scientific consensus has been that true constants, such as the speed of light and the gravitational force, remain unchanged over time. But in recent years, more and more evidence has challenged this assumption. A telling example is now posed by observed changes in supposedly constant radioactive decay rates in relation to solar flares.
In 1904, Ernest Rutherford wrote the book, literally, on radioactive decay. In this book, he states, in no uncertain terms, the constancy of the rates of radioactive decay. This allegation was initially shown to be consistent with experiment, and so was generally accepted. Not to be double-checked, monthly cycles weren't enough. Nature had yet another surprise in store for a pair of Purdue researchers. While searching for new methods of random number generation via nuclear decay, Jenkins and Fishback recorded 3 drops in manganese 54 counts of about 0.1%, corresponding with the 3 December 2006 solar flares.
One of the effects that was discovered was on the night side of the Earth, the radioactive decay decreased roughly a day before a flare appeared on the sun. And this effect was noted a number of times. So it was reproducible. The question then was, how do we get an effect happening on the other side of the Earth, on the night side of the Earth, away from the sun, being registered through the Earth?
The Purdue researchers who discovered this correlation initially tried to avoid speculating about this problem and published just the correlation, but their submission was rejected on the grounds that there was no known mechanism for radioactive decay counts to decrease in anticipation of a solar flare. Being forced to come up with a mechanism, they were later able to publish a paper where they suggest that a massive increase in solar neutrino production prior to the flare is responsible for the decreased counts. The reasoning is that the neutrino weakly interacts, and beta decay is via the weak force. Unfortunately for that theory, it was already established in 1998 that variation is present in substances which alpha decay, which is via the strong force. Neutrinos can't be the effector. So are there better explanations to be had in an electric universe?
The point is that all matter is connected in the universe. All of this suggests that it is much simpler than the neutrinos. It is this direct connection between all matter in the universe. And if quantum theory is telling us anything at all, it's telling us that it's due to resonant effects in matter, so that the atoms that are disturbed on the sun leading up to a solar flare, that disturbance, that change in the resonance of those atoms is available to radioactive atoms on Earth. In other words, this direct connection can invoke a change in decay rate.
So now we're going to go over these 4 UAPs, starting with the Apache, November 6, 2018, 3 UAPs. One thing that I noticed, you'll see on the right here, and I ask you to watch for it in the video that I'm going to show. There appears to be a spinning vortex there that you can barely see relative to these 3 UAPs. That gives us a hint of what we're looking at. So me and Steve did our analysis, and this is what we found. We're looking at Apache, the 3 UAPs. The footage shows multiple atmospheric features, unidentified aerial phenomena, UAPs, that appear as warm spots on the infrared imager flying in a formation, breaking formation, flying in loops, colliding with each other, defying all known capabilities of any craft we know of. It's our opinion that these are UAPs that exhibit observable engineered space-time effects in the near and far fields of view to the observing FLIR imager. The question remains, are the UAPs naturally occurring phenomena or artificial, e.g. manufactured? The data collected suggests these UAPs were naturally occurring phenomena, magnetic vortices associated with a pre-signal that in the future a coronal mass ejection would occur the day after the image data was collected. In the far field, we observed what appears to be atmospheric phenomena of vortex above the right and to the right of the 3 UAPs, except when the UAPs interacted together when the vortex appeared directly above the UAP. See the vortex there? Now I should just to explain this video, the Apache FLIR video was 1.5 hours long, but there was only 30 seconds of the video where we saw any of this interaction with the 3 UAPs. So that's why the shortness of it. Also, it included an audio portion where the pilots described what they saw as 3 fast-moving jets. As a practical matter, I don't usually consider the audio data along with the observational data, so to prevent it biasing the result. So at the close-up view of the 3 UAP shows what appears to be these little vortices that are interacting. Now, in the near field, we analyze the data for what's called inertial dominated intersection flows. So in what we do here is, I'll show you this, and then I'll explain when we get to the slow part. So now what's going on here is you'll notice that what we have is 200 frames. They're cropped. You'll see the little white circles around each of the data points. That shows where we've basically excluded the data outside there. We've also inverted it, so it's like in the little circles is a actual negative of what you would see. And we did that because it kind of shows the properties that it's basically dynamic, it's moving. that it appears to disappear and reappear, kind of as you would expect for an atmospheric phenomenon. So, but basically, it shows some pretty interesting features, and that's why we slowed it down. You can see structure. So now here's the interesting. There's a website where you can look at what's called space weather. And so when we looked at that website, we saw that in reference to the November 6, 2018 UAPs that they were due to this CME that occurred the next day on November 7th. And what the space weather report said is geomagnetic storms in the offing. A large hole in the sun's atmosphere is turning to face Earth and is spewing a stream of solar wind towards our planet. NASA's Solar Dynamics Observatory photographed the structure on November 7th. This is a coronal hole, a place where the sun's magnetic field opens up and allows solar wind to escape. It looks dark because the glowing hot plasma normally contained there is missing. In this case, en route to Earth, estimated time of arrival, November 10th, 3 days later. A similar stream of solar wind hit Earth's magnetic field just a few days ago, sparking G1 and G2 glass geometric storms along with auroras over several northern tier US states. A repeat performance isn't often. The sun, however, is blank. There's no sunspots. Okay, now here we're going to look at the A10 Warthog FLIR video. In this, we have one UAP. You'll see that in the display, it shows that the black is hot, and you'll notice the UAP is hot, and you'll notice the A10 Warthog is also hot compared to the UAP. They're the same temperature. Now I'm going to show you the original video. It's only about 1.5 minutes long, so.
Now, Michael, I'm not seeing any movement in the video.
Oh, you're not?
No, no, sir.
Interesting.
Is it in a different window, perhaps? Or maybe it just stalled.
Okay, let me, I can try it again. Can you see, what can you see displayed right now?
So I see the A10 Warthog FLIR video of one UAP, and then I see a picture of the UAP and the jet plumes.
Okay,
Black
now
is hot.
the video again. Now, do you see the video now?
I don't see it playing though.
Huh. Interesting. Maybe I have to share it.
You may have to, it may be in a different window that's overlaid. You may have to share that differently.
Yeah, okay, let me go. Let me start over again. Oh. I want to make sure I don't close the wrong thing. Okay, so now can you see the video there? Let's,
I'm still showing that other, I'm still showing the window in your slideshow.
okay, I'm going to stop share and then share screen again and see if we can get it to work.
Yeah, I think what was going on is you
Oh, I
shared
got
this.
it.
Yep.
I think I got it now.
There we go. Okay, and let's see. Let's hope that this
Let's
does
see
it.
if that works. Do you see the blue screen come up?
No, no, I do not. It just
You see-
shows your file manager. You shared your file manager, so it's not. Yeah, you could try sharing your entire
Huh.
screen. That might be the only way that we can do this. Unless you have sensitive stuff on your desktop.
No. Okay, let me. Okay, what do you see right now?
So right now it's just showing your file manager. I think you need to stop the share. Yeah. And trying to just share screen on the entire thing.
Share the whole screen down here. Let's see. Okay. Okay, do you see the file or the file manager now?
Yeah, now I'm seeing it.
Okay, now I'm opening the video. Tell me if you see the blue screen come up.
There we go. Okay, now I see it.
Okay, cool. Sorry about quality, folks. This is what I got. So when it changes to white, that's when it becomes white hot. When it changes to black, it's black hot. It's only about a little more than a minute and a half long, so. Okay. Can you see my presentation or do I have to stop share again?
It looks like it's back on your presentation. It looks like it's on
Okay.
slide 32, I believe.
Okay, I'm gonna go to the next slide. Is it working okay? Okay.
Perfect, perfect. And how many more do you have, Michael? Just out of curiosity.
Oh, how much? I'd say I got maybe 5-10 minutes the most.
Okay, perfect. Yeah, yeah. Go for it, man.
So, well, just give me how much time you need me to do.
Well, we have up to an hour for Q&A, right? So if you run over, we just push into Q&A. So that's
Okay.
that's one of the
Are
reasons
we
do
pushing
it.
over? Are we pushing over yet, or how far
Nah,
away?
we got like 3 minutes, but yeah.
Oh, yeah, it'll be within 10 minutes, I'm sure.
Yeah, it doesn't have to be precise. I was just curious.
Okay. Okay, so the footage shows anomalous atmospheric features, e.g. an unidentified aerial phenomena, UAP, that appears as a warm spot on infrared imager flying in loops and defying all known capabilities of any craft we know of. Upon closer inspection, the UAPs display what appears in the near field to be a spinning vortex moving in loops. That causes the UAP to appear to exhibit enormous accelerations that would crush any pilot. It's our opinion that the UAP exhibits observable engineered space-time effects in the near and far field of viewing to the observing FLIR imager. The data collected suggests that the observed UAP was a naturally occurring phenomenon, however. A magnetic plasma vortex that formed when a crack opened up in the Earth's magnetic field associated with a geomagnetic storm on the sun. So now, just a little, these are some examples to show the display of where it's like, it says WH on the display, that means white hot in comparison to the background. Notice the UAP and the A10 jet plume. Altitude and data and time displays are in the upper left there. You can see the date and the altitude there in this example. And then here we've got the opposite where it's black hot means hot in comparison to the background. And notice the UAP and A10's two jet plumes. There's a difference in the spectral bands when you go from the black hot to white hot. And you can see this as an example when you go from 1 to 2 jet plumes. Now, Steve, the image analyst, he had to do processing on the video of the A10 UAP to stabilize the raw rock back and forth, and A10 with the HUD with the display frames removed. You'll see both of those. Now, Steve noted that all the UAP approaching frames stacked in a helical oscillating motion, which he shows here. In the far field, we observed what appeared to be an atmospheric phenomena, a vortex and a wave of atmospheric particle flux towards the Earth. In the near field, we observe the UAP is what appears to be a magnetic vortex buffeted by surrounding waves of particle interaction. So now looking at the space weather again, The April 15th, 2021 UAP appeared to be due to a crack opening up in the Earth's magnetic field. A minor G1 class geomagnetic storm occurred during the early hours of April 15th when this crack opened up in the Earth's magnetic field. Solar wind rushed through the gap to fuel the disturbance. Conditions are quiet again now, is what they said. And if you look at this, there's a little graph they show here, and they show here at right around midnight, this hole opened up. It says B sub Z tilted south for 2 hours, opened a crack in Earth's magnetic field. Let's go back a little and I'll show you. The date, April 14th here. You see the time is 11:23:24 p.m. right before midnight. Also reported on the 13th, on the 15th was a sunspot. The active region has nearly a dozen moon-sized dark cores scattered across a patch of the sun's 75,000 kilometers wide. These cores are boiling in and out of existence as the sunspot transits the face of the sun. Here are 3 days action recorded by NASA's Solar Dynamic Observatory. Sunspots are essentially islands of magnetism floating on the surface of the sun. AR 2814 is more of an atoll and a very unstable one. If its magnetic underpinnings continue to shapeshift, opposite polarities could clash, leading to a solar flare or not. Okay, now we're going to look at La Bruja. It's also been called the witch. And if first let's this still shot, you see that we have black hot, means black is hot, but the UAP is cold on the IR, it's white. So now I might have problems with opening this again. Please let me know. Can you see it? Hello?
Yeah, no,
Okay.
that looks fine. Is that the Puerto Rico one?
That's La Bruja, it's called.
Ah, okay.
You don't see it in the beginning, it shows up. There you go. It's not very long. It's only 49 seconds. So see the cows? Okay, can you see the slide okay?
Yeah, La Bruja FLIR video, 1 UAP.
Okay, thank you. Okay, so this is what we found. The footage shows one anomalous feature, an unidentified aerial phenomenon that appears as a cold spot on the infrared imager in comparison to cattle, also imaged appearing hot on the imager. The location of the UAP in the vicinity of grazing cattle provides a perspective on the size and velocity of the UAP. Steve Leah provides imaging analysis showing anomalous far field effects. It is these analysts' opinion that the UAP exhibits novel, observable, engineered space-time effects in the near and far fields of view to the observing FLIR imager. The cold temperature of the UAP is unexplained. This low velocity and indifference of the cattle to the nearby phenomena suggests the feature is benign. On February 23rd, 2020, the sun is blank, no sunspots. The question remains, was UAP a naturally occurring phenomenon or artificial, e.g. manufactured? The cattle appear warm on the IR imager, and it provides a perspective to the size and speed of the white cold UAP moving behind them as they graze. You can see their relativistic speed. And now this is the far field stuff that Steve saw. For me, it would seem that some sort of intelligence is whipping up substances from the world within the quantum fields, mixing them with our classical world in a very clever way to project or mimic of our likeness and even our culture. They appear to be using known established physics like magnetic confinement and a cyclotron type acceleration of particles into a plasma that can shape to look like almost anything imaginable. I also inferred discrete signal data sets of gravitational lensing and or some type of engineered space-time metrics coming from an obvious far more advanced intelligence than anything we presently possess and I know of. These things have absolute care, custody, and control of such phenomena, seemingly having total mastery of all it has to offer. The implications of such intelligence are staggering to contemplate. As far as a sentient being contained within the inferred animal-human likenesses, I cannot say, given the hard-coded data extracted thus far. It could be merely an illusion controlled and projected from the proverbial man behind the curtain. Okay, now we're going to show the last is the rubber duck FLIR video. It's called that because it looks like a duck. November 23, 2019. We have, again, the UAP is cold on the IR. So now this original video is like 39 minutes. So I'm gonna open it and then cut into it at about 20 minutes and 30 seconds. And I'll only stay on for about a minute. Can everybody see it okay? Hello?
Yeah. Yep. No, it looks fine.
Okay, great. I'm gonna go to 20. Okay, here we go. Now I'm doing it from here is because you'll see some cows there. And now you'll see the UAP appear. And it goes on for about another 18 minutes, just like this. This is interesting where it goes over dark regions. You can see the contrast better. When you see the white regions it's going over, that's snow. So it's relatively cold to the temperature of the snow. So you see that okay, Tim?
Yes, rubber duck FLIR video of one UAP.
Okay, thank you. The footage shows one anomalous feature, an unidentified aerial phenomena, UAP, that appears as an amorphous cold spot with the intermittent shape of a duck, e.g. the rubber duck on the infrared imager in comparison to cattle also imaged appearing hot on the imager. The location of the UAP in the vicinity of grazing cattle provides a perspective on the size, distance, and velocity of the UAP. It's these analysts' opinion that this is a UAP that exhibits observable engineered space-time effects in the near and far fields of view to the observing FLIR imager. Novel was the cool temperature of the UAP and its duck-shaped morphology. The lack of sunspots may be related to the cool temperature of the vortices observed. The data collected suggests the UAP was a naturally occurring phenomenon. Magnetic vortices associated with the pre-signal future in time from a coronal mass ejection solar flare occurred the day after the image data was collected on November 23rd, 2019. In the far field, we observed the black cow is warm and the black on the imager, and the snow is cold and white. Notice the rubber duck UAP is cold on the imager and its side is large relative to the cattle size. BH means black hot is hot. There's the cows. Now, obviously, it looks like the rubber duck is closer too, so that could account for the size difference. In the far field, we found evidence of magnetic domains and vortices associated with the UAP. Far field effects were observed, suggesting magnetic field effects associated with the surface topography of the underlying terrain. Now, November 23rd, 2019 UAP is hypothesized as being due to a CME that occurred on November 24th, 2019. According to the spaceweather.com, a new hole in the sun's atmosphere, a southern hole, has opened in the sun's atmosphere and is spewing solar wind towards Earth. Estimated time of arrival, November 27th through 28th. Arctic auroras are likely when the gaseous material arrives. However, we don't yet know if this newly opened hole is capable of causing a full-fledged geomagnetic storm. Stay tuned for updates. The sun, again, is blank. There's no sunspots. So here's a summary of the results. I've looked at, I'm comparing the results of 5 UAPs by their attributes, where the Tic Tac is the control. Now, first we look at the thermal signature of the Tic Tac was warm. Yes, we observed space-time effects. Yes, we observed high G maneuvers. Artificial or natural, we conclude it's artificial or manufactured. The Apache UAPs, the 3 of them, they're warm. They're showing space-time effects. They're showing high G maneuvers, but our opinion is they're natural. The A10 UAP, again, is warm. The space-time effects, yes, are observed, and the high G maneuvers, again, were observed. Again, we considered this a natural phenomenon. The La Bruja UAP is cool. Yeah, we're seeing space-time effects. We're not seeing high G maneuvers, though. We can basically see how fast it's moving relative to the cow. Whether it's artificial or natural is still a question. It could be, there's all kinds of other things that have been suggested, from balloons to other anti-reflectance coatings, that kind of thing. So it could be artificial, but it also could be natural. The rubber duck UAP, it's cool. It's definitely showing space-time effects, and but it didn't show high G maneuvers. It appears, based on the solar data, to be natural.
We are back. So let me put this thing on gallery view. Everybody, please give Mr. Michael Boyd a giant applause. Michael, thank you. That was a really in-depth drill down.
That was fun.
Yeah. No, that was awesome. That was awesome. Thank you so much. Thank you so much. That was
Pardon going over.
lots and lots and lots of UAP footage. So